Okay, so welcome to today's lesson. We'll be looking at set interval notation. Okay, so this is a continuation from the last class, which was on the introduction to set theory. Okay, so we discussed a number of things in that class. Okay, so we are going to build up from whatever we learned in that class. Okay, so in today's class, we have the following objectives outlined here. We are going to learn the meaning of the three types of brackets that we use in set notation. Okay, and then after that we are going to know how to represent, okay, these set intervals on the number line. And then from there we'll do the most important thing, which is solving exam questions. Okay, so this is the roadmap that we are going to follow in this lesson. Okay, so from the previous lesson, when we are talking about representation of sets, okay, we said there are three ways in which you can represent these sets. Okay, so we said the first one was the descriptive form, and then the second one was the set builder form. Okay, and then the third one was the roster form. Okay, so in set theory we have mainly three types of brackets. Okay, and one of those brackets that are used to represent these sets in roster form. So the common brackets, okay, that you learned in grade 12, something like these. Okay, so these here, okay, are called curly brackets. Okay, so these ones here are used to list the members that are in that set. So for example, we can say set A, okay, as the following members. Maybe it has 1, 2, 3, 4, and maybe 5 there. Okay, so we use these kind of brackets here to list all the elements that are in that set. Okay, and we said if we are able to list members of a certain set, then we call that set as what? We said we call that set as finite. Okay, if you remember the types, so meaning we can list all the elements in that set. Okay, so now the second type of bracket is these guys here. Okay, so these guys, they will have a number here, and then you say comma, and then you have another number here. Okay, so these are called curved brackets. Okay, and they represent what we call as an interval. Okay, so an interval is just a range of values. Okay, so those who have their mics unmute, please mute yourself. You can only unmute yourself if you want to ask a question. Okay, so these brackets here are called curved brackets. Okay, you can see the curves like that. Okay, so these sets will be used to represent what we call as intervals. Okay, and these intervals are just a range of values of maybe it can be set Y, set B, it can be any set. Okay, so it just shows you the range of values in that set. Okay, so maybe we can say set A, okay, is a set that contains numbers between 1 and 10. Okay, so all the numbers between 1 and 10 will be present in this set, not only 1, 2, 3, 4, 5, 6, 7, and 9. No, okay, even 1.1, 1.1115, 2.4, 7.4, all those numbers, they will be represented in this set. Okay, so this set, when it's represented in form of an interval, then we say that set will be called an infinite set. Okay, so what is an infinite set? It is a set that contains elements that are not countable. We cannot count the numbers that are between 1 and 10. Okay, there are just so many numbers. Even if we had a set like A is equals to maybe 1 to 2, this one here, this set here, okay, the members that it has are uncountable. Okay, there are a lot of numbers between 1 and these 2 here, so it's an infinite set. Okay, so we are going to be representing these infinite sets now with 1, the curved brackets, the ones I've given you there. Okay, or 2, we can represent them using the square brackets, so something like this, and then you have a number there and then a number there. Okay, so you have a starting point for your values. Okay, Grace, kindly mute your mic. Okay, so we have a starting point for this interval. Okay, and then we also have an end point there. So the end point is B, the starting point is A. So these two types of brackets, these ones, the curved ones and the square ones, we are going to be using them to represent what? Intervals. And these intervals represents what we refer to as the infinite set, meaning the elements in that set we cannot what? Count them. Okay, so these types of brackets have a meaning. Okay, they have a meaning. So if you have this kind of bracket like that, okay, and then let me say 5 comma, okay, let me even put 10 here, and then I put that. Okay, so if you have a curved bracket here, it means that this number at the beginning here, okay, this number at the beginning here is not part of this set. Okay, is not part of this set. Okay, if you have a curved bracket like that, it means that this number at the beginning is not part of the set. Even this 10 here will not be part of the set because we have a curved bracket like that. Okay, but if I have this interval 5 to 10 and then I use square brackets here, okay, it means that these numbers at the end of this interval will be part of the set. So the first element in this set will just be 5 and then the last one will be 10. But for this guy here, we can't tell what is the first element in this set. Okay, so it contains all the elements between 5 and 10 but excluding the 5 and the 10. Okay, when we're talking about this interval here, so we don't know where exactly, okay, the members of this set are starting from, but we know that they are between 5 and what? 10. Okay, so when it comes to representing now these intervals, so I'll erase this. When it comes to representing these intervals, okay, someone has a question?
Yes, sir.
Yeah, what's your
Yes, sir.
question?
Yes, I'm a bit behind. You said that the curved and the squared brackets, they're just the same.
No, I
Is
didn't.
that what I've
I
said?
didn't say they are the same. I said they will represent, both of them will represent infinite sets, but they have a different meaning. So that's what I was trying to explain. Okay, so let me continue explaining. So
Okay.
if you have these curved brackets like this, okay, let's say 2 and maybe 4. Okay, it means these endpoints here are not included in this set. Okay, so when we get this set and try to put it on the number line, so let this be a number line and then you have a 0 there, you have a 2 somewhere, and then you have a 4 here. Okay, when we want to represent this set, we are going to say this set is from 2 all the way up to 4. You've seen the line that I've drawn there. Okay, and then because we have these curved brackets like that, okay, it means the endpoints are not included. So what are we going to do? We are going to draw an open circle on 2, and then we are also going to draw an open circle on what? On 4. So this shows that this 2 is not included in this set. Let's name this set A. Okay, so this 2 is not included in this set A. Even this 4 is not included in this set A. But all the elements between 2 and 4 are included in that set. Okay, okay? So that's what we mean when we have the curved brackets. Okay, so what about if we have let's say set B? Okay, so set B, let's have the square brackets. Okay, so if we have the square brackets, maybe we have from 0 all the way up to 5. Okay, so we have the square brackets there. Okay, so how is it going to appear like when we put it on a number line? So let this be my number line, okay, and then let this be my 0. My 5 will be somewhere there. Okay, so we are going to draw a line between 0 and 5. Okay, and then we are going to look at the types of bracket that we have there. Okay, so if you have these square brackets like that, okay, it means the endpoints here are included in this set what? B. So we're going to come on 0 here, we are going to draw a shaded circle like that. Okay, you've seen that circle has been shaded, right? Even that circle there has been shaded. Okay, so this means that this set B is from 0 to 5 with the 0 and 5 included in that set. Okay, all right, so basically this is what we are going to be using to represent these sets, which are called infinite sets on the number line. Okay, so what if you have an interval that is mixed? Okay, maybe we have one side we have a square bracket and then on the other one we have a curved bracket. So maybe we have 2 to 5. okay, and then we have a curved. So this, when we represent this interval on the number line, to just be like this. Okay, so you have your 2 there, and then you have your 5. You're going to draw a line between these 2 and 5, okay, and then ask yourself now, is the 2 included in this set? No, because we can see what, a curved bracket there. So we are going to draw an open circle on 2 like that. And then, is the 5 included in this set? We are going to say yes, because we have a square bracket here. So we are going to shade on top of 5 like that. Okay, in a similar way, we might have a situation where we first start with the one that is included. Okay, so let's say 3 to 8, and then the one that is not included. So what are we going to do to represent this guy here on the number line? So we are going to say this is 3, this is 8. Okay, then we are going to draw a line between 3 and 8. Okay, and then we're just going to ask ourselves now, is 3 included? So we come here, we see the type of bracket that is there. So if you have a square bracket there, it means this 3 is included. So we are going to shade on top of 3 like that. Okay, then you come here, you ask yourself, is this 8 included? No, because we have a curved bracket there. So we are going to put an open circle like that, and then you're going to say, this is my set B, that is my set A. Okay, so that's the meaning of these brackets, and that's how we can represent them on the number line. Okay, so any questions about the representation of these intervals on the number line before we proceed? Any question?
Hello, sir.
Yes, you can ask your question, sir.
Yes, I understand what you're explaining here, but I joined late, so I don't know what you started with. I just found you doing the number line. So I don't know
Okay.
what I had missed.
You haven't missed much. So I was just explaining about the types of brackets that we have in set theory. Okay, so I said the first ones that we have are these ones, the curly brackets, the ones you are used to from your secondary school. So we said these ones are used to represent sets that are countable, that's a finite. Okay, so you can count the members in those sets, and then these are curved brackets like this, okay, or the square brackets like this. We said these two here, 1 2, they are used to represent infinite sets, so sets where you can't count the number of elements in that set. Okay, so I was saying this square bracket here means that the endpoints are included, and then if you have a curved bracket, that means it means that the endpoints are not what included. So that's what I was explaining there.
All right. Thank you
Right.
very much.
So I hope we are all on the same page. Okay. So usually when you have questions on representing these uh, set intervals on the number line, okay, you are usually given a universal set to work with. Okay, so we are going to be given a universal set. Okay, sometimes they can say the universal set is from minus infinity all the way to positive infinity. Okay, sometimes they can just give you a normal interval. They say maybe the universal set is from 10 to minus 10 to 10. Okay, so it means this will be the biggest set that you would work with in that specific question. Okay, so this set here that I've written from minus infinity all the way to positive infinity, this set is called the set of what, real numbers, and it is represented by a capital letter what, R. Okay, so real numbers are represented by the set, the open ended set from minus infinity all the way to positive infinity. So in this set here we have all the positive numbers and all the negative numbers, including what, 0 itself. So when you draw it on the number line, we're going to put 0 on the middle. This will be minus infinity, that will be positive infinity. Okay, if you want to represent the universal set there on the line. Okay, and then from here we'll be putting the Tuma sets that we are given. Maybe some of the sets is starting from here, ending there, starting from there, ending there. Okay, and then we can find whatever we want to find. So when we are using these set intervals, okay, and you are asked maybe to find the, when you are asked to find the intersection, maybe A intersection B, okay, how are you going to get the interval of A intersection B? Okay, you are going to say, okay, let's say maybe A is from here all the way up to there. Okay, this is my set A. Okay, and then let me draw my B maybe from there all the way up to there. Okay, so for you to find A intersection B, you are going to go at the point where the line from A is overlapping with the line from B. Okay, so we can see here where they are overlapping, it's this part here. Okay, so your answer will just be this part here. So you are going to get the number that will be here and the number that will be there as the interval that is describing what? A intersection B. Okay, so what else do I have to explain before we solve the questions? Okay, so one more thing is the complement. Okay, because I see a lot of students struggle with the complements. Okay, so remember how we define the complement. Okay, so let's say if A is from 2 all the way to 5, okay, and this is a set that is closed. Okay, and then we say the universal set is from minus infinity to positive infinity, meaning the set of what? All real numbers. Okay, so and then they ask you to find maybe a complement. So what do you do? Okay, what do you do? So when it comes to this interval notation, you are first of all going to draw your number line. Okay, you can put your 0 there, your minus infinity as the starting point, your positive infinity as the end point. Okay, and then we are going to plot this set A. So set A is from 2 all the way up to 5. Okay, so we are going to shade this circle because we have a square bracket there. Even there we're going to shade this circle, and then this will be our A. Okay, so now how do you find your set A complement? Remember we said complement are just all those members that are not a part of that set, right? Okay, so for you to find your complements, you are going to go at the end point of this set A or whatever set, okay, you've described. You're going to go at the end point. So I'm going to go at this end point 2 there. Okay, and then you ask yourself, is this 2 included in this set A? Okay, if your answer is yes, then you just go above this A and draw an open circle. Okay, and then go to the opposite side like that. So all these members here starting from 2, but this 2 is not included in this set, will be a part of the what? The A complement like that. Okay, so please understand what I'm explaining here. If you don't, ask me to explain again. And then you go at the end point of 5 here, you ask yourself again. So let's change this so that we can see the difference. Let's change this. So let's put an open circle at the end point of 5 there, and then there let's put a curved like that. Okay, so we go at the end point of this A, which is 5. We ask ourselves, is this 5 included in the set A? Okay, our answer is no. So just go on top here, you are going to draw a shaded circle, and then you are going to go to the opposite direction like that. Okay, so this also will be a part of your what? A complement. Okay, so we have two parts of the A complement there. Okay, so we are going to say this A complement is equals to, the first part is starting from minus infinity all the way to 2, but this 2 is not included because I have an open circle there. So we are going to say, okay, minus infinity, comma, 2, and then curved bracket like that, because this 2 is not included. Okay, so by the way, if you have minus infinity or infinity, never use the square brackets like this. Okay, for minus infinity, positive infinity, always use the curved brackets the way they are. Okay, so this will be the first part of the A complement, and then we are going to say we are jumping this part which is in between. Have you seen the yellow part there? So we are going to say union. Okay, and then we come here where the other A complement is starting from. So the other complement is starting from 5 all the way to positive infinity. So we are going to say this 5 here is included in the A complement because the line for A complement has a shaded circle there. Okay, so we're going to say square bracket 5 comma positive infinity, and for positive infinity, negative infinity, we always use a curved bracket like that. Okay, so I've explained all the basics that you need to solve these questions, okay, when you are asked to represent them on the number line. Okay, so any questions there before we do some practical exam questions now? Okay, so all right, so Sheba, you have a question you can ask.
Sir, could you please go through the example that you just gave?
Okay, so in this example, we're trying to find the A complement. Okay, so I gave the set A, okay, as the set that is starting from 2 all the way up to 5, with these 2 being included because we have a square bracket like that. Then this 5 here is not included. Okay, so we want to find this A complement here. So what do? We first of all plot this set A. Okay, so if we plot this set A on the number line, it will be a line that is starting from 2 all the way up to 5. Okay, but since we have a square bracket here, it means 2 is included, so we put a shaded circle. And then here, since we have a curved bracket, we put an open circle on 5. Okay, and then now we want to find the A complement. So what do? We go at the end points here. So the first end point here on 2, the 2 is included in the set A. So it means in the A complement, the 2 won't be there because it's in the set what? A. So you just go above these 2 and draw an open circle, and then you go to your left like that. Okay, so this here will be the first part of your A complement. Okay, and then the other part of the A complement will be this side now. So you go at the other end point there, which is 5, and then you ask yourself, is this 5 in the set A? No, because I can see an open circle there. Okay, so it means I'll just go above it and draw a closed circle there. I'll draw a closed circle, meaning this 5 here is actually in the A complement. Okay, so a closed circle there, and then we draw a line all the way to positive infinity. So you have 2 parts now that are in the A complement, this one here and this one here. So how are we going now to represent that? We are going to combine them. So the first part there is just from minus infinity to 2, and then you say union because we are combining with the other part, which is starting from 5 all the way to positive infinity there. Okay, so I hope it's clear now. Okay, so can we proceed to the questions now?
Sir,
Yes.
I'm sorry, my network tripped. I didn't get when you said explaining on the white lines. Continue from somewhere else.
Okay, so I was simply explaining there. We are just finding the A complement. Okay, we are just finding the A complement there. So you go at the end points of this A. Okay, you ask yourself, is this 2 is in this A here? No, so it means I mean this 2 is in the set A, so it means it won't be in the A complement. So you draw an open circle there, and then you go to your left like that. So this will be the first part of the A complement, and then you also go at this end point. Okay, you ask yourself, is this 5 a member of set A? So since we have an open circle there, it means it's not a part. Okay, so we are going to draw a closed circle on top, and then we go to the right. Okay, and then we just unionize this part here and this part to be our A complement. Alright, so I think you understand more when we do some examples. So let's do some examples now. Okay, so this is our first question there. Okay, so that's our first question. So in our question, they are saying, given that R, okay, which is the set of all real numbers, is the universal set, okay, and A is a set from minus 8 to 6, B is a set from 5 to positive infinity. Okay, find A complement. 2, find B complement. 3, find A minus B. 4, find B minus A. Okay, so let's get our universal set. So our universal set is the set of real numbers. So real numbers start from minus infinity all the way to what? Positive infinity. Okay, and then we have our set A, which is just from minus 8, which is not included, to 6, which is included. Okay, so you check the types of bracket that you have. And then we also have B, which is from 5, which is included, to positive infinity, which is never included. Okay, so how are we going to find the A complement? Okay, it's simple, just the same as we did on the previous question there. Okay, so we are going to say this is our number line. Okay, so on this number line we are first of all going to plot our universal set. So our universal set is from minus infinity all the way to what? Positive infinity. And then we are going to put a 0 somewhere. Okay, somewhere we're going to put a 0. So let's say the 0 is here. Okay, and then our first question is to find the A complement. So we are dealing with this set. So what we are going to do is that we can write minus 8 somewhere here, because we know minus 8 comes before 0. Okay, and then we can put 6 somewhere there. Okay, so now we draw a line between this 8 and 6 like that. Okay, let me use a different color. So we draw a line between this 8 and the 6. Okay, so at 6 we're going to draw a closed circle like this. At 8 we're going to draw an open circle. Okay, so this will be our set A. Okay, and then how are we going to find the complement now? Okay, so the complement, we come at the endpoints. So at this first endpoint here, we see that this 8 here is not included in the set A. So it means this 8 will be included in the what? The complement of A. So you go to the left side. So this will be the first part of A complement. And then you come at the other endpoint, which is 6. Okay, you ask yourself, is this 6 included? We see that it's included because we have a shaded circle there. So it means in the A complement it won't be there. So you draw an open circle and then you go to your positive infinity. So this will be the second part of our A complement. Okay, so now we get the set A complement. So we're going to say A complement is equals to, the first part will be from minus infinity all the way to what? To minus 8. Okay, so we see that this minus infinity is never included in any set. And then at 8 here we see that this line that I've drawn in green here, okay, it is shaded at 8, at minus 8. So it means this 8 is included. So you draw a square bracket there and then you say union, and then you get this part here. So this part, we have a 6 here and an open circle. So it will be curved bracket 6 all the way to what? Positive infinity. So this one here will be our set A complement. Okay, right, I hope that is clear. So let's find the B complement now. Okay, so I'll erase this. So let's find the B complement. So the B complement, we are going to follow the similar steps. Okay, going to follow similar steps. We are going to say, let this be my universal set from minus infinity all the way up to positive infinity, and then I can put my 0 there. Okay, let me put my 5 here, and then I'll draw a line from 5 to positive infinity. So the 5 is included, so you shade the circle and then you go all the way to positive infinity like that. Okay, and then what are we going to do? So this is our set A. Okay, this is our set A. Our set B, I mean, not A. Okay, so this is our set B here. So how are we going to find the complement of B? Okay, we go at this endpoint. So for this set here, there's just one endpoint here. There's nothing you can do to this endpoint here because it's going forever up to positive infinity. Okay, so there's nothing we can do to that endpoint. So we only have one endpoint here. So you ask yourself, is this 5 a part of set B? We see that yes, it is. So it means in the A, why am I always saying A? In the B complement, we are not going to have 5. Okay, so you draw an open circle on 5 and then you go all the way to positive what? Or you go all the way to minus infinity there. Okay, so this here will be our B complement. Okay, and we see that our B complement will just be the set from minus infinity all the way to what? To 5. And this 5 is not included, so we draw a curved bracket like that. Okay, so that will be our set B complement. Okay, right, so now let's do A minus B. Okay, let's do A minus B. So A minus B, remember in our first class how we defined the difference of two sets. Okay, so before you even solve it, just make sure you simplify it. Okay, before you solve it, make sure you simplify it. So we know that A minus B, by definition, okay, we know that this here is the same as A and then this minus b becomes intersection b complement. We agree, right? That's what we learned in the first class. Okay, so it means here we are intersecting set A with the B complement. Okay, so what are we going to do? We're first of all going to draw the B complement. Okay, so we are just from drawing the B complement. So this was 5, and then we had an open circle here all the way to minus infinity, right? This was our B complement, right? Okay, so this is our B complement, and then we are trying to intersect this B complement with the A. Okay, so our A is starting from minus 8 all the way up to 6. So I'm going to draw a line between this 8 and 6 like that. Okay, you see that the 6 is included, and then the the 8 is not included like that. So this is my set A. Okay, so we are finding the intersection of this set A with the B complement. So what are we going to do? We're just going to go to that part where the line for B complement and A complement are overlapping. Okay, so overlapping, which it means one line is on top of the other one. Okay, so that part is from 8. Okay, this part where I'm shading 8 all the way up to what? To 5. Okay, so we are going to say A intersection B complement is equals to. So now we come at this endpoint. So listen carefully here, guys. We come at this endpoint here. We ask ourselves, is this minus 8 a part of both the set A and the set B complement? Okay, so we see that in the set A it's not there because we have an open circle there. Okay, this is an open circle, and then in B complement is there because we have a solid line that is passing through uh, this minus 8. Okay, so because that minus 8 is not in both of these sets, remember intersection takes the common element, right, in both sets. Because this minus 8 is not in both of these sets, we're going to write a curved bracket here and then minus 8 comma, and then we come at this other end here. So we are at 5 here. So we see that 5 is in the set A because there's a solid red line that is passing by this 5. Okay, so meaning this 5 is in the set A. But when we look at the set B complement here, we see that we have an open circle there, okay, on 5. So it means 5 is not in both the set A and the set B complement. So we are going to write 5 and then curved bracket like that. So this here is our answer to what? A minus B. Okay, so any questions there? Okay, I think it's quite clear. So let's solve the last one, which is B minus A on question 1, and then we go to question 2, which is a bit more involving. Okay, so we are going step by step, okay, so that we get the concept. Okay, so for B minus A, this is the same as B intersection what? A complement. So we are going first of all to find the A complement here. So set A, okay, if this is my 0, this is my 8, and this is my 6. Okay, so set A is from 0, I mean from minus 8. Or someone has a question?
Yes, sir.
Yes.
Why is it that B minus A isn't A union B complement?
Why is it that what?
I'm saying, why is it that B minus A is not equal to A union B complement?
Is not equal to A union B complement. This is what you're asking?
Yes.
No, that's not correct. Okay, so by we are just using the definition there. Okay, so we said when we are subtracting two sets, okay, it means that this minus whatever set is at the end here, it just becomes intersection, and then we have the complement of that set. Okay, so there is no such definition where we have A union B complement. No, we don't have such a definition. Okay, so we're just using a definition there. All right, so let's plot the set A there. So the set A is from minus 8 to 6, where the the 6 is included, the 8 is not. So this is my set A. And then for me to get my A complement, okay, I'm going to come at this endpoint. I forgot to write the universal set here, which is from minus infinity to positive infinity. So at this endpoint, the 6 is included. It means in the A complement, it won't be included. So this will be my A complement. Here, the minus 8 is not included in the A. So it means it will be included in the what? The complement. And then I go to minus infinity there. So this is my A complement. Okay, so now let's draw the set B, okay, in blue. Okay, since we've drawn the A complement, now let's draw the set B. So we see that the set B is starting from 5 all the way to positive infinity. So 5 can be between 0 and 6, right? So we can put our 5 somewhere there. Then we have the positive infinity. So now let's draw the set up here. So the 5 is included in the set B. So I'm going to shade this. And then I'm going all the way to positive infinity like that. Okay, so this is my set B. So to find the elements that are in B intersection A complement, we are going to go at the point where the line for B is overlapping the line for A complement. So we can see that that point is this part here. So this part here all the way to what? Positive infinity is overlapping with the what? The A complement. So we are going to say this A intersection B B intersection A complement to just be a set that is starting from 6 all the way to positive infinity. Now you ask yourself, is this 6 included in that set? Okay, no. Why? Because in the A complement we have an open circle there. Okay, but in this B it's included because we have a solid line passing through this 6. Okay, so since this 6 is not included in both the A complement and the set B, we're going to write a curved bracket like that, and then we put 6 comma positive infinity, and we know that infinity, whether negative or positive, we always have to add a square bracket like that. Okay, so this here is our answer for B minus what? A. Right. Okay, so we are done with question 1. We are going to go to question 2, which is a bit more technical. Yeah, someone has a question?
Yes, just repeat on the last part.
Which part?
On the last part where you're saying A, the complement where you've shaded with white.
Where I've shaded with the A complement with the B.
With the white. Yes, yes, yes.
Okay, so I was saying we are shading the part, okay, we are shading the part where this blue line of B, okay, this blue line of B is overlapping with the green line of A complement. Okay, so we see that this blue line here and this green line here are overlapping starting at this point here and then going all the way to what? Positive infinity. So that will be our intersection for this set B and the A complement here, because here where we have another A complement we do not have any set B here, so there is no intersection this side. So the intersection is only this side, and it's starting at 6 all the way to what? Positive infinity. Okay, with the 6 not being included. Why? Because it's not included in the A complement there. Okay, so that's how we ended up with 6 to positive infinity like that. All right. Right, so let's look at question 2 now. So this is question 2 here. It's a bit more complicated, so pay attention. Okay, so here we've been given a specific universal set, not the entire set of real numbers. Okay, so let's read the question. They're saying let the universal set be the set from -3 all the way to 9, with both -3 and 9 being included in that set. Okay, and then they're saying then set A is -1 to 5, set B is 3 to 7, set C is -2 to 8. Okay, and then they're saying for each of the following sets, they're saying find each of the following sets and clearly display them on the what? The number line. Okay, so the first set that we are finding is B complement union C complement. Okay, so we are working with these sets here. So the union will just be from -3 all the way to 9. The set A is from -1 all the way to 5. The set B, okay, is from 3 all the way to 7. And then the set C is from -2 all the way to what? 8. So this is what we have there. Okay, this is what we have. So what are we going to do in order to find the B union C? The B complement union C. Okay, so B complement union C complement. Okay, so this is a special set. Why? Because it's part of the De Morgan's laws. Okay, so I sent a video, I think in a group that was talking about the De Morgan's laws. Okay, so if you have B complement union C complement, this here is the same as B, okay, intersection C. You put them in brackets and then you put the complement outside. So how does this come about? Okay, is when you expand this set. So if you say complement multiplied by this B, you're going to get B complement. Complement multiplied by the intersection, it changes to the union, and then complement and the C, you have your C complement here. So this set that I have here is exactly the same as this. Okay, and this is one of the De Morgan's what? Laws. Okay, so you have to know how to prove this using sets like the assignment that I gave you, or you have to know how to prove it without even being given the sets. Okay, so I sent the video there, make sure you watch it. All right, so finding this set here is similar to finding this set here. So we're just going to find B intersection C, and then we're going to take its complement. That's all. Okay, so let's plot these guys on the number line. So this is my number line here. Okay, let me make it a bit straight. Okay, so if this is my number line here, okay, so this is my number line here, and then let me have a 0 somewhere. So we are considering which set? B and C. Okay, so let's say we have a 0 there. Now I have to get the pens. Okay, so let's say we have a 0 here. Okay, and then the universal set, remember, is from what? 3 to 9. That's our universal set. So the lowest value is -3, which is included, so you can actually shade the last part like that. And then the highest number is 9, which is also included in the universal set, so we can actually shade the last part like that. Okay, so this is our universal set, -3 to 9. So now let's plot the set B. Okay, so the set B is starting from 3 all the way to 7, somewhere there. Okay, and then the set C is starting from -2 all the way to 8. Okay, so let's plot the set C first of all. So the set C will start from -2 all the way to 8. We see that -2 is not included. Okay, and then we go all the way to 8, which is also not included. So this is our set what? C. And then let's plot the set B now. So the set B, we see that the 3 is included here because we have a square bracket, and then the 7 is not. So we are going to draw a shaded set circle there, and then we go all the way to what? To 7, like that. Okay, so this is our set B. Okay, so remember, B complement union C complement is the same as B intersection C and then complement outside. Okay, so where is this set B and C, where are they intersecting? Okay, so we see that they are overlapping from here. Okay, from 3 all the way up to 7, they are overlapping here. We have a green line on top of the blue line. Okay, so that what I've shaded there will be our set what? B intersection C. Okay, but our interest or our answer is not the B intersection C. We want its complement. Okay, so we are going to go above. Okay, so at this starting point of this set A intersection B, we are going to go above we are going to draw an open circle because this one here is shaded, and then we are going to go all the way up to what? To minus 3. So minus 3 is included. Make sure you shade it. Okay, and then we are going to go again on top of this 7 here. So the 7 is not included in the B intersection C, so it means it will be included in their complement, and then we go all the way up to what? 9, like that. So we have two parts of the B complement. The first one is this one. This is our B complement. The second part is this one. This is also our B what? Complement, like that. Okay, so for us now to write out the final answer, we are just going to combine those things that we have there. Okay, so let me create some space here. All right, so we know that this is B complement. Okay, so we are going to say our set B complement union C complement is the same as B intersection C complement, which is equals to, okay, the first part here is starting from minus 3 all the way up to what? 3. So the minus 3 is included, so I'll put a square bracket and then comma. This 3 here is not included. Is the 3 included or not? Okay, we said the 3 is not included because we have an open circle there. So we are going to say 3 and then curved, and then we are going to say union, and then we get this other part. Okay, so the other part is starting from 7, which is included, comma, all the way up to 9, which is also included. Okay, so this one here will be our set B union C complement. Okay, so any questions there on how we are finding these things? Okay, no question. Let's solve the second one. Okay, so the second one is involving, but we are going to deal with it anyway. Okay, so the second one there, it's a big set, so you can first of all try to simplify it. Okay, if you want, you can first of all try to simplify. So let's write it down. So we have universal set minus C complement intersection, okay, A minus B. So this is what we have. So before you even draw this set on the number line, always try to simplify whatever we have. Okay, so we know that those two are minus inside, we can write them as something else. So I'm going to say this is union. Okay, this minus C here, we know that it becomes what? Intersection C complement, and then we have another complement outside there. Okay, intersection the way it is, then here we have A, and then intersection. Okay, this minus B becomes intersection B complement. Okay, so this is the set that we now have. Okay, so from that set, okay, from that set we have the union, we have the universal set intersecting the C complement. Okay, so what is the universal set intersecting the C complement? What do you think we will have inside that set? Okay, what is the universal set intersection any of its subset? Come on, guys. What is the universal set intersecting any of its subset? Okay, let me put it in a picture. So if, for example, this is my universal set, right? And then inside here I have a subset of this universal set. Let's say this set here is A, and then this box here is the universal set. So what is the universal set intersecting A? Hello?
Sir, can I try?
Yes, yes.
I'm thinking it's A.
Exactly. Okay, so when you get the universal set and then you intersect it with anything, it's just going to be that set that you are intersecting with. Okay, so it means in the brackets here where we have the universal set intersecting the C complement, okay, we are just going to remain with C complement there, and then we have a complement outside, and then intersecting, then we have A intersection B complement there. So you've seen how simple this expression is turning out to be, right? Okay, and then after that we are going to multiply, okay, this complement with this complement. So when you multiply a complement with a complement, they cancel out each other. So there we're just going to remain with what? C. And then this C intersecting, and then we have A intersecting B complement there. So we have this set now to plot on our what? Our number line. Okay, so we've simplified this big set here that was intimidating. Okay, we've simplified it into this uh, very nice set. Okay, so we can plot this easily and then we find our answer. Okay, so now let's plot this guy. Okay, let's plot this guy. So let's create some space here. Okay, so we said all this set here will just turn out to be what? C intersecting A intersecting B complement. That's what we said. Okay, so first of all we are going to find A intersecting B complement. Okay, and then that intersection where A is intersecting the B complement, we are going to intersect it with the C. Or we can go the other way where we draw the set C, the set A, and the set B complement, and then we check where the three lines are going to be what? Overlapping. Okay, I think let's go with the second method there. So let's draw these sets now on the number line. So this is my number line. Okay, remember our universal set is from 3, so I'm going to put -3 there. It's from -3 all the way to +9. Even this +9, make sure you shade it, okay, because it's included. All right, and then let's put 0 somewhere here. Okay, let's put 0 somewhere there, and then we can have a -1 there, and then a -2 there. Okay, and then on the positive sides we can have 5, 7, and 8. Okay, so just pick the numbers that you can see there. There's no need for you to write all the numbers because this is interval notation. Okay, so you can say 5, 7, and then 8. Okay, so let's first of all plot the set. Let's plot the set B complement because it's the one that is difficult, okay, or the one that involves a lot of things. So I've missed out a 3 here, okay, on the numbers. So let's put a 3 there. So 3, and then we have 5, and then we have 7, and then we have 8. Okay, so the set B is from 3. The 3 we can see is included, okay, all the way up to what? 7, and the 7 is not included. So this is our set B. Okay, from that set B we are going to come up with our B complement. So our B complement will be, we go at the end point of this B, okay, we draw an open circle, then we go all the way to -3, which will be shaded like that. So this will be the first part of the B complement. Okay, the other part of the B complement will be, we'll go on this 7. So since this 7 is not included in B, it means it will be included in what? The B complement. So we are going to shade this part, and then we go all the way to 9, which is also shaded like that. Okay, so this will be our second part of B complement. And then now let's plot the set A. Okay, so the set A is from -1 all the way up to 5. So -1 all the way up to 5, with -1 not being included, we draw an open circle, and then we are going all the way to 5, which is included. So that's set A there. I've drawn it in blue. I'm going to label this as A. And then I'm left with which set now? I'm left with the set C, which is outside here. So the set C, we're going to draw it in green. Okay, so set C is starting from -2 all the way up to 8, and both the -2 and the 8 are not included. So I'm going to draw it on top here. So I'm going to say -2 is not included. Okay, and then I'm going all the way to positive 8, which is also not included like that. So this is my set C, right? Okay, so now you ask yourself, where can I see the set B complement A and C overlapping? Because here we have all signs as what? Intersection, intersection, intersection. So we just want that part, okay, where the blue line of A the yellow line of B complement and the green line of C are overlapping. So where is that part? Okay, so we can see that that part will simply be this part here. So we start shading here. We see we have green, yellow, blue. Okay, so you shade, 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 shade. We see that it's ending there. Okay, so we see that the part that we are looking for, okay, is just starting from -1 all the way to 3. Okay, and then now it's just a matter of asking ourselves, is the -1 included, is the 3 included? So we first of all go on this -1 here. Okay, so we see that the -1 is not included in the blue line there because we have a circle in blue, but it's included in the yellow and the green because we have a solid line that is passing uh, by the -1 there. Okay, so since the -1 is not in all these sets, we are going to say curved bracket -1 comma, and then we come on this 3 now. So on 3 we see that in the blue line it's included because the solid blue line is passing by 3. Okay, and then in the yellow line we have an open circle there, which means the 3 is not included. And then in the green one it's also included. Okay, since it's not included in one of them, we're just going to say 3 curved bracket like that. Okay, so that will be our answer there. So we're just going to say this set here is equals to -1 and then 3 like that. So this is our answer here. Okay, so just solve your question step by step. You'll be able to find whatever you are looking for. Okay, so don't hurry, don't rush yourself, just solve it step by step. Okay, if you are given a complicated set, make sure you try to simplify it first and then you draw the lines on the number line there. All right, so any questions on what we've done or on this question? Okay, someone in the comments saying, do they allow to use more colors of pens? No. I think it's not a problem. You can use blue and black. Okay, but here I'm using these different colors for the sake of your understanding so that you can see. Okay, but you won't be having all these colors with you of pens unless you are an artist or something like that. Okay, so just learn the skill, learn to differentiate that. Okay, this part I'm putting it as my B complement, as my C complement, just like that. Okay, so any questions, guys? Any questions? All right, then we are done for today's lesson. This was the lesson for today. I hope you've learned how to do the set interval notation, guys. Okay, so if I give you a question, I don't expect you guys to get it wrong. Okay, because I've taught you the basics here. Okay, I've taught you all the basics there. Okay, so someone is saying I didn't get anything on the last part. Okay, it's fine, I totally understand. I'm going to share this video once we are done, okay, so that you can watch it again. Okay, whatever concept you didn't get, make sure you watch it and then you understand better. Okay, so now I'm going to give you an assignment to do. Okay, so this is the assignment here. You can take a screenshot, okay, and then you try to solve it. Okay, so when you solve, always you can share your answers with me. I'll be able to guide you where you are doing it wrong and where you are doing it rightly. Okay, so thank you so much, guys. This was the class for today. Have a blessed night.